Hari Om. Today let us discuss about Wheatstone bridge. First of all, what is a Wheatstone bridge? It is a combination of four resistors, a galvanometer, and some circuit elements which form a certain type of combination. For example, as you can see in this diagram, we have four resistors P, Q, R and S. Along with these four resistors arranged like this, we also have a galvanometer, battery for potential difference source, a key. This arrangement forms a type of bridge which we generally call as Wheatstone bridge. It has got many applications. Basically, what happens for a given choice of PQRS means at a certain condition no current flows through the galvanometer, that is Ig becomes 0. So let us try to derive that relation, and for that here we will apply both the laws of Kirchhoff, that is junction rule as well as loop rule. First of all, let us consider that I current is being generated in the circuit. That I current will divide into I1 and I minus I1. This we have done using Kirchhoff's junction rule, and Ig current flows through the galvanometer, and after making the arrangement of current in all the branches, again I amount of current is flowing in the circuit. Now we have two loops here, loop L1 and loop L2. Just we have to apply Kirchhoff's loop rule, that is the sum of potential drops across all the elements in a given loop is 0. So if you apply Kirchhoff's loop rule for loop L1, you can see that, let us start from the point, and when we are moving along the direction of current, that is the direction of our motion and the direction of current is same, then we take the potential drop to be positive, and if our direction and current's direction is opposite, we take it to be negative. So this equation will become I1 into P plus Ig into G minus R into I minus I1 is equal to 0. Let's check that. Similarly, for the loop L2, we will get Q I1 minus Ig minus S I minus I1 plus Ig minus Ig G is equal to 0. If you have doubt in applying Kirchhoff's second law, that is Kirchhoff's loop rule, you can watch another video that I have already made. If you don't have any doubts now, we can proceed. And as we had discussed, in balanced condition, no current flows through the galvanometer. That is, Ig is equal to 0. So let us put that in both of these equations. If we put Ig is equal to 0 in equation 1, our equation 1 will become I1P minus R I minus I1 is equal to 0, which we can write like this, that is I1P is equal to R times I minus I1, and we can simplify this to be I1 by I minus I1 is equal to P by R. Let us denote this with equation 3. Similarly, if we put Ig is equal to 0 in equation 2, we will get I1Q minus S I minus I1 is equal to 0, or I1 by I minus I1 is equal to Q by S. Let us denote this as equation 4. Now if we compare equations 3 and 4, you can see that the LHS are same. That is I1 by I minus I1 is same in both the equations. So our equation will become P by R is equal to Q by S. This is the balanced condition of Wheatstone bridge. If we cross multiply and again divide certain things, or by arranging, we can write P by Q is equal to R by S. This is also another balanced condition of the Wheatstone bridge. That is, if P by Q is equal to R by S, then no current flows through the galvanometer. Or you can say it in the other way around, that is, if no current flows in the galvanometer, that means P by Q is equal to R by S. Alright, this is the balanced condition that we are talking about. Okay, let us stop here today. We will proceed to the next part in the next video. Thank you.